We'll now start looking at polynomials. So the first question should be, what is a polynomial? And in order to determine that, we're going to start with a monomial. A monomial is anything of this form, a times x to the k. In this case, a can be any number, and k needs to be a non-negative integer, things like 0, 1, 2, 3, 4, etc. The next one I want to look at is a binomial, and this is the sum of two monomials. So if I take two of my monomial terms and add them up, I have a binomial. The next one is a trinomial. A trinomial is the sum of three monomials. And a polynomial is just a general sum of monomials. Any number of monomials is known as a polynomial. I want to define two more terms for polynomials before I start looking at examples. The first term is degree. The degree is the highest exponent of the variable. If I look at all of my variables in my polynomial and look at their powers, their exponents, I want the biggest one. The next thing I want to define is terms. The terms are the actual monomials that we added up to actually make our polynomial. And now that we have all these definitions, let's start to look at examples of all of them. I'm now going to look at several examples, and I'm going to give you the polynomial, and then I'll discuss the type of polynomial, the terms in the polynomial, and the degree. My first polynomial, 7x to the fifth plus 2x squared minus 4x. You can see three different things added up here, which is going to make this a trinomial. The actual terms are the monomials that we add together. For this one, that's 7x to the fifth, 2x squared, and minus 4x. The degree is the highest possible exponent on the variable. Here I have exponents of 1, 2, and 5. So my degree would be 5. My next one, 9x plus 2. There are two things added together here, which makes this a binomial. My terms, I have a 9x, and I'm adding a 2. I only have one variable here that has a power of 1, so my degree would be 1. My next one, 9 plus 8x squared minus 4x to the fourth plus 1/2 x to the sixth. This one actually has four things, so it's just a generic polynomial. It doesn't have a special name. I have a 9. I then add an 8x squared, so that's my next term. My third term, negative 4x to the fourth. And then my final term, 1/2 x to the sixth. If I look at my exponents, the biggest one is going to be this 6, so my degree is 6. I now want to look at x squared plus 2x. We can see this has two terms, so it's a binomial. I have an x squared, and then to that I'm adding a 2x. So our degree is the largest exponent on the variable, which is 2. 10x to the fourth, this has a single term, so it's a monomial. Like I said, there's just a single term, 10x to the fourth, and the exponent on the variable is a 4. The last one I'll look at is just the number 4. Once again, we're just adding one thing, so we have a monomial. The term is just 4, and since there's no variable at all, the degree will be 0. I now want to look at adding and subtracting these polynomials. My first step here, the first thing to notice here is I have these parentheses, but since I'm just adding, the order of addition doesn't matter. So these parentheses don't matter. From there, I want to look at like terms. So in particular, things that have the same variable and exponent. We have a 3x to the fifth and an x to the fifth. Adding those together gives me 4x to the fifth. I have a 7x to the fourth and a 2x to the fourth. We know that 7 plus 2 is 9, so that's a 9x to the fourth. I only have a single x squared term, so I'll just write that one down. I then have an 8x and a negative 9x. We know that 8 minus 9 is negative 1, so that's a negative x. And then I have this negative 3 that can't combine with anything. So now I have my solution. I now have the same problem. I changed it slightly by making this negative. The first parenthesis is not going to change. It's going to stay exactly the way it is. However, whenever we have a negative sign in front of parentheses, we need to distribute it all the way through. So we need to change the sign all the way through that parentheses. Negative x to the fifth minus 2x to the fourth plus 9x. And from there, we can start combining like terms. For my x to the fifth, I have a 3x to the fifth and a minus x to the fifth. 3 minus 1 is 2, so 2x to the fifth. I then have a 7x to the fourth minus 2x to the fourth. 7 minus 2 is 5, so that's 5x to the fourth. This minus 3x squared term doesn't combine with anything. And then I have an 8x plus 9x. We know that 8 plus 9 is 17. So that's a plus 17x. And then minus 3 that doesn't combine with anything.